My name is Nicholas Rosen. I am in your 6th period science class. Now, on my project for Newton's 3 laws of motion, I have chosen to do a video. Along with this video is a program called MS Paint, which I will be using to give visual examples that goes along with what I'm saying. Now, without further ado, let's get on to Newton's first law of motion. The law of motion is the law of inertia, which basically states that a still object will not move unless it is moved by an unbalanced force, and a moving object will not come to a halt unless it is stopped by an unbalanced force. Now, what this means is that if a car were stationary in a parking spot, just imagine this is a parking spot right here, it will stay there until it is moved by something strong enough to move it. Now, the thing that would be strong enough to move it is a person. Now, the person, which acts as the unbalanced force towards the car, will give a force of enough newtons to move the car slowly out of the parking space. Example of the law of inertia could be a soccer ball on a soccer field. The soccer ball is currently stationary, it is not moving, it will not move unless it is acted upon by an unbalanced force. An unbalanced force could be a soccer player. The soccer player will kick the ball, applying force to the ball at, let's say, 12 newtons, that way. Now, applying the force to the ball through his leg will direct the ball that way at 12 newtons, and the ball will eventually lose speed over time. The law of inertia could be a table. Now, the table is stationary. It will not move unless it is moved by an unbalanced force. The unbalanced force could be a stick person who just came home, he's exhausted, he had a horrible day at work, and he's just so tired, and he's so angry because a project that he's been working on forever and ever, for weeks and weeks, got denied by his boss, and he's very angry about that. Now, what he will do to this table is flip it over angrily at a force of, let's say, 30 newtons. Now, the table will fly into the air the same direction the force was applied. It will flip up into the air and go the same direction the force was applied. The law of inertia is important, and it affects us in everyday life because we drive cars around, push carts around the grocery store, and play sports that we could not do without the law of inertia. The law of motion is called the force law. The force law basically states that the force of an object is its mass multiplied by its acceleration. The example of the force law could be a stick person, 2 stick people actually, and this stick person just hates the stick person right here so much that he took the time out of his day to throw a small stone that will probably land somewhere near his leg. Now, this small rock has a mass of about, let's say, 5 grams. And it is moving at a speed of maybe 15 miles per hour. Now, this rock that is 5 grams and moving at 15 miles an hour will have a force of 75 newtons, because 15 times 5 is 75. Now, this rock will probably not hurt very much, because it's a small stone, it only weighs 5 grams. It might cause a small bruise or a cut. Now, this person will be okay, do not worry, and this person right here, this person right here told on his mom, and this guy's in trouble. So, don't worry. The force law could be the same scenario with the 2 stick people, except that the rock that will be thrown this time weighs 1 kilogram, which is equal to 1,000 grams. Now, this rock is still moving at 15 miles per hour because this guy has a great throwing. He is part of the basketball team for his school. Now, this rock will be moving at a speed of, let's see, 1,000 times 15 would give us 15,000 newtons. 15,000 newtons. Now, this rock, thankfully, will hit the ground before it hits his knee. Now, if this rock were to hit his knee, it would probably break his leg, and that's bad. So, again, this guy went and told on this person's mom, and he got in trouble yet again. Wow. Example of the force law could be the same person who got almost hit with stones twice, going on a hike in the mountains. And then he sees this huge boulder, and he thinks this boulder must weigh at least 30 kilograms. Thankfully, it's moving at a speed of 0 miles per hour, which means it's standing still. Now, if we were to calculate this object's force, we'd do 30 times 0, which would get you 0 newtons of force. Now, thankfully, this rock doesn't have any force. It is stationary. It will not do any damage to him. However, if this rock were moving at 20 miles per hour, you would do 30 times 20, would give you 600 newtons of force. And a rock with this amount of force and this size, he probably wouldn't be able to outrun it, and he might get crushed by the boulder, and that's bad. Law of force is important because we have a way of confirming if an object will cause damage or not via mathematical equation. The final law is called the action and reaction law. This law basically states that if something hits an object, the object will retaliate against the object with the same force it was hit. The action-reaction law could be a person who just jumped straight in the air and came back down at a force of 14 newtons. He let it on the floor's rumbling a bit. Now, the reason it's rumbling a bit is because 14 newtons just got applied to that floor, and his legs are probably going to ache because the floor exerted the same exact amount of force, 14 newtons, back up onto the floor into his legs, which probably caused an ache or two. And if he did this, a couple times, he'd probably get tired and he probably wouldn't want to step on the floor anymore. The action-reaction law could be when you high-five somebody. Now, these two stick figures are best friends. They've just got done playing a game of sports, and they both made great shots, maybe 20 million shots of their basketball game, and they're so happy, and they're gonna high-five with a force of about 5 newtons for this guy, and maybe 6 newtons for this guy, because this guy's a bit stronger. Now, when they high-five, the 5 newtons will be applied to his hand, aching him a bit, but it will also apply back to him, aching him as well. Now, the 6 newtons that he will apply to his hand will also hurt at a force of 6 newtons, but that same force will go over to his hand at 6 newtons. Now, the amount of force per hand would probably be 6 plus 5 being 11, so these people's hands are currently experiencing 11 newtons of force onto their hands, and that's why whenever you high-five, your hands sting afterwards. Another example of the action-reaction law could be whenever you hit a baseball with a baseball bat. Now, this baseball player here is a professional player, and he will probably swing the bat at around 180 newtons. Now, the ball bounced off the bat because he hit a perfect hit out of the park. There it goes, home run, 80 newtons onto that ball, but the ball exerted the force all the way down to the bat, into his arms, at 180 newtons, and that's gotta ache quite a bit. And this is also why your arms and hands ache, maybe your shoulders a bit, ache after you hit a baseball. The action-reaction law affects us by making us feel something, such as pain, when we apply force to an object. This concludes my presentation on Sir Isaac Newton's 3 laws of motion. And remember, none of this video would have been possible without Isaac Newton. So remember to donate to your local Sir Isaac Newton charity today. Your penny can make a difference and go towards finding the 4th law of motion.